Okay, so here's another question where we need to solve a permutation equation using the actual permutation formula here. So we know that n plus 1 permute 2 will give you 2. So let's start off by writing out the formula. So NPR is equal to n factorial over n minus r factorial. All right, so we are given quite a bit of information here. So first of all, n is essentially n plus 1 here, and we're permuting 2 objects at a time. All right, so instead of n now, I'm actually going to replace that with n plus 1 factorial. On the bottom now, that's the same thing for n here. So n now becomes n plus 1 minus the r, which is given by 2. All right, factorial. So once again, we can go ahead and simplify this. Now we know the value of this side here. This value is equal to 2. So I can go ahead and substitute 2 in now. So 2 is equal to n plus 1 factorial on the top here, and you'll see that we'll have some like terms on the bottom here. So 1 minus 2 is just simply n minus 1 here, okay? All right, so here we go. We want to go ahead and get rid of the factorials now. So you want to try to simplify the bigger one quantitatively. So quantitatively, the one that's the biggest is the one on the top here, okay? Because we have that plus 1 there. So I'm going to go ahead and rewrite that until I get an n minus 1 factorial. So n plus 1 is the first term, and then I have n, and then I have n minus 1 factorial. All right, so you want to stop there because I want to get rid of the n minus 1 factorial on the bottom. So you see that we can cancel these two expressions now. What I'm left with here is something much easier to look at. 2 is equal to n plus 1 times n. So as you can see here, we have a quadratic. We just go ahead and get rid of those brackets first. So n squared plus n, then bring everything to one side to make it equal to 0. I'll just bring the 2 over. So 0 is equal to n squared plus n minus 2. So we go ahead and factor that using just PSA1. Once you factor it, you should get 2 binomials that look as follows. N plus 2 times n minus 1. So algebraically, when we solve this here, we're going to have 2 possible solutions. N is equal to negative 2, and n is equal to positive 1. So once again, we do have restrictions on the actual on the n value, and can't be negative. We can't arrange a negative set of objects. So negative 2 cannot work here, so that's considered extraneous. So the only solution for n here is n is equal to 1.